Algebra 2, Lesson 100, Graphs of Parabolas. So we're going to be going to our coordinate plane system today. To understand the graph of parabola, we have to understand the general form of a parabola. The general shape of a parabola. Parabola is either a smiley face like this or a frowny face like this. Right? So it's just a curve, and the curve has a vertex, right? Right, and then the vertex will run across what's called an axis of symmetry. The axis of symmetry will cut the shape directly in half, like so. And they generally follow the form of an equation that is set up like this, where y would equal x squared. So, really quick, just to show it to you. The graph of y equals x squared, it's going to look like this. So if we were to take an x and y table and we solve for y equals x squared, and we were to plug in values just like a linear equation, I could plug in, like 3, 1, 0, -1, -3. And then if I were to plug these values into x, 3 squared would be 9, so y would be 9, 1 squared is going to be 1, 0 squared is 0, -1 squared is still positive 1, -3 squared is still positive 9. So when we go to graph these points, we'll see 3 and then 9, so that's 1 point right there. And we have 1, 1, that's another point, 0, 0, then -1, 1, and then lastly, -3, 9. Right? So you can kind of see how this would give us the shape of our graph, because it's a curved line that goes up like this. Right? So that gives us the shape of the parabola. Now you can adjust this equation with different numbers. I'm going to show you how to do that now, especially with quadratics, because that's what we've been doing a lot of work with lately. So we're going to learn how to we're going to learn the general form of the equation, then we're going to learn how to convert a quadratic into that form, and then how to graph a parabola. So first let's start with the general form of the graph of the parabola. So the general form, if we were to write it correctly, would be y equals x plus h, or sorry, not plus, x minus h. X minus h squared plus k. All right, now what is h and k? H and k, or h comma k, are the x and y coordinates of the vertex for our parabola. If you remember, the vertex, I said, was the starting point, right? Either the lowest point or the highest point, right? So that would be like the vertex. Now, the thing you have to notice about this equation is it's x minus h. So if you're looking at a solved parabola, let me find one in the book. If we're looking at a solved parabola like this, y equals x minus 2 squared minus 2, the negative h means that h is always going to be the opposite of whatever number this is. So since this is -2, the actual value of h is positive 2. So for this parabola right here, the vertex would be at 2, and then k is going to remain the same sign, so it would be 2, -2. So for h and then k. And we know that this point would be the vertex of our parabola. So we'd go to 2, we'd go -2, and that's going to be the vertex of our parabola. Now there's another blank in this equation that we need to look for, and that is right here. Okay, so right now you see nothing here, right? Which means that this number is positive. But if it's positive, it's going to open upwards. So a positive parabola makes a smiley face, right? Now if this space had a negative in it, that would make a downward parabola, or a frowny face. So positive, smiley face, negative, frowny face. All right. Now, if you look at this equation, we see that it's positive, so we know our parabola is going to open up. So we would find our vertex, we would sketch our axis of symmetry right here, and then we would just draw an upwards parabola. And then we've successfully graphed y equals x minus 2 squared minus 2. So the main numbers we need to look for in our parabola are the space before the parentheses, whether it's positive or negative, the opposite sign of the x value, and the value of the k right there, or the y value. So let's take a sheet of paper, and how much time we're at? We're at 5 minutes. You know what? Let's practice graphing another one really quick. We'll graph one more parabola, and then from there I'll start showing you how to use complete the square to graph. So let's say we get this parabola. Let's say we have y equals negative x plus 4 squared plus 3. So the three numbers we're going to look at, or the three places we're going to look at, are here, here, and here. Now remember, the x term is going to be the opposite sign. So the vertex of our parabola is going to be negative 4, which is the opposite sign, and then the same sign as this one, 3. So these two numbers give us the vertex. So if I go to negative 4, positive 3, that is the vertex of my parabola. Now I'm going to look right here. Is that positive or negative? It's negative, so that means my parabola is going to open downward. So I'll sketch the axis of symmetry. And then from here, I draw a downward parabola. All right, so that one is done being graphed. Okay, so this general form of the equation is very, very important. But whenever we get most of our quadratics, they look like this. They'll look like, well, let me find one. They'll look like this. Y equals x squared minus 4x plus 2. Now this is very different from this. So this one is in the standard form for a parabola. This one is not. So the question is, how can I take this quadratic, put it in this form so that way I know how to graph it? We're going to use complete the square. So we'll go to our paper and we'll figure out how to write this in general form. Now remember, the form we want to get to is y equals plus or minus x minus h plus k. So, well, I was off camera. So this is the form we want to get to. This is the form we're at. So we got to figure out how to write it this way. We're going to use complete the square. Now, normally when we use complete the square, our equation's equal to 0. But in this case, it's equal to y. So what we're going to have to do is we're just going to have to work on the right side of the equation. So just like with complete the square, I want to not work with this last term. So what I'll do, since I can't move it to the other side, since my equation's not equal to 0, is I'll do this. I'll put x squared minus 4x, and I'll put that in parentheses, and I'll leave a blank there for the third term, and then I'm just going to put plus 2 on the outside. Right? So that way I can still do complete the square inside the parentheses, and I don't have to bother this 2. Now when I do complete the square, if you guys remember, we're going to take this middle term, negative 4, we're going to divide it by 2 and then square it. So negative 4 divided by 2 gives me negative 2. Negative 2 squared gives me positive 4. Once I have positive 4, I add that here. Now normally I would add that to both sides of the equation, but since I don't want to disturb this y on the left side, what I'm going to do is I'm going to add 4, and then I'm going to subtract 4. Right? Because normally the goal is we add to both sides of the equation, so we're not changing the equation. But if I add 4 and subtract 4, I essentially just added 0 to the problem. So I didn't change the number, I'm just changing the way it looks. So add 4, subtract 4, okay? Now, once I do this, I have a perfect square. And this can be factored into that perfect square, right? So x squared minus 4x plus 4 can be factored into x minus 2 squared, right? The minus 2 comes from negative 4 divided by 2, right? So x minus 2 squared. So I'm going to write it like this. And then here, all I have to do is combine these terms. 2 and negative 4 combine to become negative 2. And then if you look at the left side of the equation, which hasn't changed, I now have y equals x minus 2 squared minus 2. All right? Now that fits the form of this equation, because now I have x minus a number in parentheses, and then I've got a number on the outside. So I'll look at these 3 points, and then we'll graph it. Now the 3 numbers I want to look at are whether or not that's positive or negative. Since there's no sign there, I know it's positive. So that means my parabola is going to open upward or be a smiley face. Then I'm going to look at this number. I want the opposite of that number, so I'm going to put 2, and then this number. So I've got a vertex at 2, -2, and my parabola opens upwards. So I go to my graph, and I go to 2, -2, put my vertex, and then I'll draw my axis of symmetry. And then from there, I know that it opens upwards, so I'll go to the vertex, and I just draw an upward facing parabola. And that's it for this lesson. If you guys have any questions, let me know on Moodle, and I will see you in class.